بسم الله الرحمن الرحيم الحمد لله رب العالمين والصلاة والسلام على خاتم الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. This is Math 101 Major 2 Term 222. Let us have a look and solve the exam together. Well, the first question is about matrices. Given matrices A and C, and we need to find A times C T or C transpose. So A is 4, 3, 2, 5. We need to multiply A by the transpose of C. Well, the transpose of C, we write the columns, the rows. Let us write each row of C as a column. So 2, 1 is the first row. It would be the first column in C transpose. 0, -2 is the second row. It would be the second column in C transpose, and then 3 and 4. So this is C transpose, okay? You change the rows of C into columns. So now the size of this matrix is 2 by 2. We have 2 rows and 2 columns. And here, how many rows? 2. How many columns? 3. So can we multiply these two? Yes, we cancel this with this. And the result, the product matrix, will have dimension 2 by 3. So there will be 2 rows and 3 columns. Now, how to multiply? We start by multiplying the first row of A by the first column of CT, okay? So you multiply this row by this column, and you write the answer here. So how to multiply? 4 times 2, that's 8, plus 2 times 1. So 8 plus 2 is just 10. So you may just write 10, okay? And we do this again. Now we multiply the first row by the second column. So 4 times 0 is 0, and 2 times -2 is -4. Then the first row by the third column. 4 times 3 is 12. 2 times 4 is 8. 12 plus 8 is 20. So now we have the interest of the first row in the product matrix. We do the same for the second row. So multiply the second row of A by the first column of CT. So 3 times 2 is 6. 5 times 1 is 5. 6 plus 5 is 11. Now the second row by the second column. 3 times 0 is 0. 5 times -2 is -10. The second row by the third column. 3 times 3 is 9. 4 times 5 is 20. 20 plus 9 is 29. So this is the product matrix. Now we need to find A inverse. Well, this is a 2 by 2. Whenever we have a 2 by 2 matrix, there is a formula to find A inverse. It is 1 over, we find first 1 over AD minus BC. So multiply 4 times 5, which is 20, minus 2 times 3, which is 6. So this is a number. That's just 1 over 14. We multiply this number by the same matrix, but we do some changes. 4 and 5, we change their positions. So we write 5 here and 4 here. 2 and 3, we keep the positions, but change the signs. So I'll have -2 here and -3 here. So that's the inverse matrix. Or 20 minus 6 is 14. So I can multiply this matrix by 1 over 14. So I can write it 5 over 14, -2 over 14, negative 3 over 14, and 4 over 14. This is A inverse. If you want to simplify this, negative 1 over 7, 2 over 7, or you can just keep it like this. Now this is A inverse. If you multiply A inverse times A, you will get the identity matrix. Okay, here we have an equation AX equals B. A inverse is given, B is given, and the question find the matrix X. Whenever we have AX equals B, we can find X. We can solve this equation for X if we get rid of A. Well, we cannot divide matrices. There is no B over A here. There is no division between matrices. So how can we get rid of A? We multiply by A inverse. A inverse times A would be I, identity. Identity times X will be X. So X will be A inverse times B. So we multiply both sides by A inverse. This would be always the answer. Well, he gave me A inverse in the question. And he gave me B also. So multiplying these matrices will give you X. Now this is what is the dimension or the size of this matrix? 3 rows by 3 columns. Here, how many rows are there? 3 rows by 1 column. So we can multiply these two matrices and we will get a matrix of size 3 by 1. So this would be the size of X. So how to multiply? Again, to multiply these two matrices, we multiply the first row by the first column. There is only one column in this matrix. So 1 times 3, 3. 2 times 1, 2. 3 plus 2 is 5, because 0 times 2 is 0. 0, now the second row by the column. 0 times 3, 0. 1 times 1, 1. 2 times 2, 4. 4 plus 1 is 5. You can do that by the calculator. You can multiply 4 times 3 plus 1 times 1 plus 2 times 1. 4 times 3 is 12, plus 1, 13, plus 2, 15. So this would be the matrix X. Now $400 interest. So this is the interest. This amount is the interest earned on a principal of principal, that's P. So the principal is 2,000 and the interest is I, $400 at a simple interest rate. So we need to use the formula of the simple interest. Well, the simple interest formula says that the interest is equal to P, which is the principal, times R, which is the annual interest rate, times T, time in years, okay? This is time in years. So simple interest rate of 5%, this is R, in fact. R is 5%, but we write it 0.05. We divide 5 by 100, so it would be 0.05 interest per year. For how many years was the principal invested? So T here is missing, okay, the number of years. So I, the interest is given in the question, which is 400. The principal is also given, which is 2,000, times R, which is 0.05 times T. And now we need to solve this equation for T. Well, to solve it for T, T would be equal to 400 divided by 2,000 times 0.05. So if you multiply 2,000 times 0.05, you get 100. So T would be 400 over 100, that's 4 years. So the number of years would be 4 years. If you invest 2,000 at a simple rate of 5% interest per year, after 4 years, you will get $400 as an interest. Jasmine invests $2,658. So what is this? This is the principal, okay? In a retirement account with a fixed annual interest rate. Annual interest rate, that's R, okay? Compounded continuously. Well, compounded continuously, there is a formula for that. And the formula says that S equals P times E to the power RT, where S is the future value, P is the principal, R is the annual interest rate, and T time in years. So here P is given, R is given. What will the account balance? So he is asking for S. After 15 years, that's time in years, that's T. So P here is given 2,658 times E, this is the number in the calculator, E, to the power R, which is 9%. How do we write it? 0.09. We divide by 100, okay? So it's 0.09 times T, the number of years, which is 15. Now, if you use the calculator and multiply this number, you will get the answer as the balance would be $10,253. Okay. Ryan invests a sum of money in a saving account with a fixed annual interest rate. So what is the annual interest rate? That's R. So R is, divide this by 100, so 0.0431, okay? Compounded monthly. Monthly means the number of periods per year, which is M, is 12. Okay, the number of interest periods or periods, if compounded monthly, then M is 12. Compounded, the formula here is S equals P times 1 plus R over M to the power M times T, where M is the number of periods per year. So if it's compounded monthly, 12 periods in a year. After 10 years, so that's T time in years, number in years, number of years, the balance reaches this amount. So this is the future value, okay? The balance reaches this amount. What was the amount of the initial investment? The amount of the initial investment, that's B. So the principal is needed here. So you can find P here. If you want to solve this equation for P, you can divide S by all of this, okay? 1 plus R over M to the power MT. So what is S? It is the future value, 12,855.94 divided by 1 plus. What is R? 0.0431 divided by M, number of periods per year, number of periods per year, times T, number of years, which is 10. So replace T by 10 and use your calculator to find the answer. And you will find that the answer is 8,361. So this is the initial amount, in which if you invest this amount for 10 years, this are compounded monthly, you will get after 10 years $12,855. Use Gaussian elimination or Gauss and Jordan to solve this system. Well, we start by writing the augmented matrix. So we write all the coefficients of x in the first column. So 2, 1, 1, these are the coefficients of x. Then the coefficients of y, 3, 2, 1. Then the coefficients of z, 4, 2, 2. And then we write the numbers in the right-hand side. Well, I need 1 in this position. So instead of dividing by 2, I will interchange row 3 and row 1. I can write 1, 3 or 3, 1, it doesn't matter here. So I'll have 1, 1, 2, 2, and the second row, I'll keep it as it is. 1, 2, 2, 1. And the first row will be the third row. And now I have 1 in this position, so I need all the other numbers. I need to make them zeros. So to make this one 0, I multiply row 1 by -1 and add it to row 2 and replace the result by row 2. And to replace or to change this 2 to make it 0, I multiply the 1 in the first row by 2 and add it to row 3. When we do that, the first row will not change by these 2 operations. But now, -1 plus 1, this would be 0. -1 plus 2, this would be 1. -2 plus 2, this would be 0. -2 plus 1 is -1. So this what would happen to row 2 when we use this operation, transformation, -R1 plus R2. Now let us do the second one, -2R1 plus R3. So -2 times 1, -2 plus 2, that's 0. -2 times 1 plus 3, that's 1. -2 times 2 is -4 plus 4, that's 0. -2 times 2 is -4 plus 2, that's -2. And now the first column is good. The second column, this number in the middle should be 1. Well, it is 1. Now, if we want to use Gauss elimination, I will make the one below 0. If you want to use Gauss and Jordan, you can make these two numbers, the one above and the one below zeros. I'll keep using Gauss elimination only. So I need to change this one to 0 to make it 0 using this one, okay? So -2 plus 3. This will make, using this one, will make this one 0. The first row as it is, the second row as it is, there is no change. I'm changing only the third row here. So by multiplying row 2 by -1, this 0 will not change. The 0 below. -1 plus 1, now I'll have 0 here. This is a 0, it will not change the 0 below because -1 times 0 is 0 plus 0, that's 0. Negative times -1 is 1 plus -2, I'll have a -1 here. And now we should make this number 0, but we can't. So that's really the last form, the reduced form. So let us write the equations again. If we write the equations again, the last equation would be 0 equals -1. The second equation would be y equals -1. And the first equation would be x plus y plus 2z equals 2. But the last equation would be 0 equals to -1. And this is impossible, okay? This is impossible, rejected, it can't be. So this system has no solution. This system has no solution, or it is inconsistent. We can say the system is inconsistent. What did he say? To solve the system. So the system has no solution, okay? You can say that the solution set is fine, or you can say the system is inconsistent. The graph of the feasible region of the objective function is given. Good. The graph is given. Find the maximum and minimum values of the objective function and the point at which it exists. Good. The graph is given and the corner points are there. So that's excellent. All what we need to do is to make a table and write all the corner points here. So this corner point is 0, 10. This corner point is 6 and 4. And this one is 8 and 0. And we have also the origin 0 and 0. And we substitute with these corner points in z, the objective function, which is 400x plus 30y. So if x is 0 and y is 10, 40 times 0 plus 30 times 10 will be 300. If x is 6, y is 4, then 40 times 6 plus 30 times 4 will give you 360. If x is 8, y is 0, z would be 40 times 8, that's 320. If x is 0, y is 0, z would be 0. So now, what is the maximum value of z? Well, maximum value of z is 360. At which point 6 and 4. What about the minimum value of z? Minimum value of z is what? 0, this one, where at the point 0, 0. So, and the point at which it exists, this is the complete answer to the question. Use the Simplex method to minimize this function, subject to these constraints, and assume that all variables are non-negative. Good. The first step in the Simplex method is to introduce the slack variables, S1 and S2. We change each inequality here to an equation. So x plus y, the first inequality we write it, x plus y plus S1 equals 24. And the second inequality would be 3x plus 2y plus S2 equals 60. So we introduce these two slack variables. And then the objective function, we bring everything to the left-hand side. So I'll have negative 40x, negative 350y, and plus f equals 0, because nothing left in the right-hand side. Now, to write or the initial Simplex tableau, this is the initial Simplex tableau. We simply put the coefficients of x. So we have the coefficient of x here is 1, and in the second equation 3, and in the objective function the coefficient of x is negative 40. The coefficient of y is 1 in the first equation, in the second equation it's 2, in the objective function it is negative 35. The coefficient of S1 in the first equation is 1. There is no S1 here, so the coefficient is 0, and no S1 here, so the coefficient is 0. S2 is not there in the first equation, but the coefficient of S2 is 1 in the second equation, and there is no S2 in the objective equation. So the coefficient of f, there is no f here, there is no f here, there is an f in the last equation, and the coefficient is 1. And here the right-hand side, we write the numbers in the right-hand side. So the number is 24, the number here is 60, and in the right-hand side we have 0 here. So this is the initial Simplex tableau. And now we do a pivot operation. So we need to determine the pivot elements. So how to determine the pivot elements? We look to the last row, the objective row, and search for the most negative number. So I have negative 35 and negative 40. The most negative number is negative 40. So negative 40 will determine the pivot column. So the column of X is the pivot column. Now to determine the pivot number, whether it's 1 or 3, we divide 24, this number, by 1, by this number. So the answer is 24. Okay, and we divide 60 by 3. So 60 divided by 3 is 20. The smallest is 20, so this says that 3 is the pivot entry, the pivot element. So we need to change this 3 to 1. So what should we do? We should divide each number here by 1 first. So we will have 1, 1, 1, 0, 0, 24 without any change. And let us divide the 3 by 1. So I'll have 1, 2 divided by 3, 0, 1 divided by 3, 0, and 60 divided by 3 is 20. And these numbers are the same. Negative 40, negative 35, 0, 0, 1, and 0. And now I need to use this number, which is 1, to make these two numbers 0. So negative R2 plus R1 and 40 R2 plus R3. Okay, R3. So the second row is not going to change. 1, 2 over 3, 0, 1 over 3, 0, 20. Let me change this one. 40 minus 40, that's 0. 40 times 2 over 3, that's 80 over 3, minus 35, I'll get minus 25 over 3. Okay. And 0 will not change anything. Now 40 over 3 plus 0. And 40 times 20, 800 plus 0, so I'll have 800 here. And negative 1 plus 1 is 0. Negative 2 over 3 plus 1 is 1 over 3. Negative 0 plus 1. Negative 1 over 3 plus 0. Negative 0 plus 0. Negative 20 plus 24. Now, these numbers here in the last row should be all positive for the process to stop. But I still have a negative here. There is only one negative. So I divide 40 divided by 1 over 3. Well, 40 divided by 1 over 3 is just 12. Okay. So I have 4 divided by 1 over 3, that's 12. And 20 divided by 2 over 3, it would be 60 over 2, that's 30. So 1 over 3 is smaller. So, 12 is smaller than 30. So 1 over 3 is the pivot element. Let me now make it, I need to make it 1. So I will multiply the first row by 3. So I'll have 0, 1, 3, -1, 0, and 12. And these numbers will be the same. Also the numbers here. There is a 0 here and 800. Okay. In fact, this number is 1, it's not a 0. And also this number is f, it is the coefficient of f. All right. And now I'll use this one to make these numbers 0. So -2 over 3 R1 plus R2. And 25 over 3 R1 plus R3. So the first row will be as it is. And now the second row. This will not change. -2 over 3 plus 2 over 3, that's 0. -2 over 3 times 3, that's -2 plus 0. -2 over 3 times 1, that's 2 over 3 plus 1 over 3, that's 1. Anything times 0 plus 0 will be 0. -2 over 3 times 12, that's 12 over 3 is 4, -8 plus 20, that's 12. And that's it, okay? This is the new row 2. Now row 3, 25 over 3 plus 25 over 3, that's 0. 25 over 3 times 3 would be 25 plus 0, that's 25. 25 over 3 times -1, that's -25 over 3, okay? -25 over 3 plus 40 over 3, I'll have 15 over 3, and that's 5. And 0 will give you no change. -25, it's +25, okay? +25 over 3 times 12. So it's 25 times 4, and that's 100, plus 800, so I'll have 900 here. And now this is the last tableau, because all the numbers in the objective row are zeros. So what would be the solution? Use the Simplex to maximize. What would be the maximum value of f? Well, here now we have basic variables and non-basic variables at the end. So whenever the column is 0, 1, 0, this means that x is a basic variable, okay? And the value of x, 1 times x equals 12. So x is 12. Also, y is a basic variable because 1, 0, 0, okay? So the value of y, 1y, is also equals to 12. So, and here, the non-basic variables are S1 and S2. At the end, we put the non-basic variables zeros. So this would be zeros, 25 times 0, 5 times 0, and we will have f, which is 1 times f, equals 900. So what this table suggests is the maximum value of f is 900, and it happens when x is 12 and y is 12. I'd like to check my answer. So here, this is f, this is f. If I multiply 40 times 12, that's the value of x, plus 35 times 12, that's the value of x, I'll find the answer is 900. So now I am satisfied with the result. This is, in fact, the solution of the last question. And have a nice time and study well.